this talk that Bob's given brings the first year of the Topos Colloquium to a close. And I thought it would be nice to just say some remarks about the year that's been, what's coming up after we return from a break next year, and then maybe to pick up some of the remarks that Ilya set up, just about remembering why we run this organization and why we run this colloquium and how it's in service of a larger goal. So what's happened this year? First, I want to begin by thanking David Spivak and Tim Hosgood for running this excellent colloquium series over the past year. It's been just a fascinating series of talks and a very, very strong effort. And of course, I want to thank all the speakers. There've been, as it says on the slide, 39 talks throughout the year, and they all remain recorded on YouTube, and I know continue to get many, many views. And so reflecting on this, one thing that Tim and I did yesterday was just grab all the titles and abstracts and put together a word cloud, which you can sort of pick up some of the themes that have gone on just looking at the abstracts in the colloquium over the past year. Of course, a lot of category theory and topos theory and type theory. Looking at it sort of in more detail, we sort of identified these four sort of major themes, right? The point of the colloquium is really to gather as a community and hear from leading figures about what people are thinking about and the interesting themes in research at the moment. And so we see these sort of four themes emerge. One is applications of category theory, which is no surprise at this institute, especially to dynamical, interacting, intelligent physical systems. We had some great talks. For example, David Spivak's opening talk about polynomial functors really set the tone for that. There've also been a very strong representation from pure category theory, interesting sort of sub-series formed around sort of probability theory and category theory and monoidal and higher categories. We had a wonderful collection of talks on logic and foundations, including, for example, a series on homotopy type theory started by Dan Christensen, and then Emily Reel, Steve Audi, Mike Schulman, and then another great couple of talks I really enjoyed on proof resistance for example, Lean's Math Library by Kevin Buzzard and Jeremy Alvegard. And throughout this all, as Ilyas kind of alluded to at the beginning, an implicit theme has been mathematics and its relationship to society, especially in the present moment. So John Baez gave a very talk that really directly addressed this about sort of what mathematicians can do in light of the current climate crisis, whereas people like Xiaowei Lin talked about how these tools, these foundational tools like proof assistance that we're developing can be used to give greater access to access to computing technologies to people who do not sort of see themselves as coders or computer literate. So in light of this, we will be continuing the colloquium next year. It's an amazing series, I think. And we'll start again in February after a break. And we're sort of more explicitly going to bring out these four themes or variants of them, which we've identified as ethics and societal impact of computer science and mathematics, applied category theory again, these sort of foundational topics, category theory, type theory, logic and foundations, and then the translation to technologies and tools through programming languages, libraries, and other tools. So I'm pleased to say we'll be back, and I look forward to you all joining us then. Other events that we're going to be running in the next year, it's sort of a growing series, and this is just the beginning. We'll relaunch the seminar in Berkeley, hopefully with the pandemic dying down. It's nice to have a crowd here gathered today. So we'll have a in-person series every Monday, and I hope those of you that can join us will join us. The MCAT seminar has been running monthly. That's about building the community, about the work of PhD students, and that's lovely. We'll launch a new sort of virtual research seminar called the Categorical Interaction Seminar, which picks up this work on what might be termed categorical interaction or cybernetics around categories of machine learning, open games, and active inference, neuroscience, and that sort of thing. We're going to have a successor to last year's workshop on polynomial functors held around the same time in March. So another week-long workshop bringing together leading figures in category theory working on polynomial functors. And there's much more to come. including, for example, lectures aimed at a much more public audience. So on that note, I'd like to return to what Ilias was saying about the mission of this organization, and that the mission is to shape technology for public benefit by advancing sciences of connection integration. And so we see this colloquium series as really about how to think about this statement and how to enact it. And that's something we've been exploring over the past year and trying to really pin down. So what is this organization about? The plan for impact is as follows, right? To begin with these fundamental research topics, creating a new mathematical system science, which provides a foundation for talking about questions such as the nature of communication or cooperation or collective intelligence, integrated cognition. But also to acknowledge that fundamental inquiry, while incredibly important and curiosity-driven and sort of foundational to the spirit of humanity, can be also used and I think should be used to serve humanity. And so it's not just this foundational inquiry, but the deployment of the ideas through technology, technology in particular geared towards a public view, right? So because these ideas about communication and cooperation, we think they can provide a very suitable foundation for the large-scale systemic problems that face humanity today, including things like AI safety and what it means for increasing penetration of technology into society, or coordination around global issues like climate change and modeling what happens in a really large dynamical system, right? But then even that is not enough. I mean, we all know that you can build powerful technologies, but we've seen, through the past few decades, from the atom bomb to social media, that powerful technologies are general purpose and they can be used in various ways. And so we take seriously this question of what is our role as mathematicians and computer scientists in ensuring that this technology does indeed benefit the public. And so that's a proactive stance from our part in terms of, bringing in the required, referring to the required expertise and bringing in the required experts to understand the impact that we're having and how to better shape it and give the public a voice in it. So we're building this pipeline from sort of fundamental mathematical inquiry, like the talk we saw today, through to this social change that we hope and that we envision. And to sort of give a sense of this pipeline concretely in the work that's been happening over the last year, I want to sort of skip through 3 examples of recent work or work in progress. So these are 3 of the current major research themes at Topos. And so the first emerging work is this beautiful paper by David, which has gone on the archive a couple of weeks ago now, about aggregation in databases. So this is about how do you answer questions such as, given a database, how much do Canadians spend on cell phones in 2021? Right, and so this is a problem of organizing the information, of selecting, all these transactions that indicate, a cell phone purchase or whatever, and then also this aggregation of the information into a single statistic, into this number that represents the answer to our question. And to provide sort of nice, uniform foundational structures for this, allows a deeper understanding of what is going on, that gets at these questions, what are the fundamental structures that underpin communication and systems? And then from there, it's the translation of this into technology. So this is a wonderful simulation from Evan Patterson's work, which is essentially about hot water. But there are sort of 3 physical systems going on here. One is sort of, these are essentially rods, heat sort of transmitting rods. And so you've got diffusion of heat within those rods. But then it's in contact with this fluid that's flowing. So you have the Navier-Stokes equations governing how that works. And then you have, of course, convection within that liquid due to the heat present. And so what is needed then is these structures of integrating these different fields of knowledge into a single, in this case, model or equational structure, which can then be simulated like this. And so this fundamental inquiry turns into libraries, tools such as this, which apply not just to these multi-physics situations, but to many problems such as pandemic modeling, where you have these different models that come from the biological sciences and epidemiology, economics, public policy. And you need to sort of produce a coherent vision of the whole without necessarily having a single overarching party that is capable of really understanding the situation holistically. So we begin to answer questions like, how can domain experts use this fundamental research to cooperate on important large-scale problems? But then the third step of the pipeline is to acknowledge also that, you know, we have these experts, we build these tools, but this is not going to be, in the present moment, where the larger public interfaces with these things. And we need to build further towards how experts, domain experts, how the public communicate. And so this work by Valeria de Paiva on natural language processing across the scientific and in particular mathematics literature. So behind this all is a corpus of category theory papers, and it extracts out these relationships such as, I don't know, Cartesian closed categories capture proofs of intuitionistic logic. So this begins to provide an interface from the way that, say, in this case, mathematicians write and communicate their knowledge to the structured knowledge systems that are in the previous step of the pipeline. And as we move forward to 2022, then we have this mission statement to shape technology for public benefit by advancing sciences of connection and integration. So far, the emphasis has been on these scientific fundamental science that drives this work. But the deeper questions are, how do we shape technology for public benefit? And what are the further steps along this pipeline? And so across the next year, we'll sort of delve more deeply into not only how do we, again, proactively anticipate the impacts of this work, understanding how this work will or can shape society, but also how to invite society into shaping the research process itself through, you know, an appropriate public engagement, through exposition, teaching and mentorship, public communications, and so on. So that's in terms of events, what's to come, and in terms of our work, where we're driving at in 2022 and beyond. Just to conclude today and bring sort of this final Topos public event of the year to a close, I want to just end with some reflections on what's been a big year for Topos, and also a thank you to the people that have been involved. So this has been a big year in the sense that really this is Topos's first year. Before January 1st, it was a bunch of volunteers with some sense of a common vision. On January 1st, we were an organization with employees and missions and meetings and so on. And while we began in this virtual sense, and our first events were virtual through the beginning of the year, we began to, you know, throw some events that gesture at the breadth of the mission, from this workshop that again brought together leading experts in category theory, a wonderful sort of list of names, and you can see their faces there, together with here, this Finding the Right Abstractions for Human Flourishing Summit. So this is David Dalrymple at the Future of Humanity Institute at Oxford, and Jan Talon, and both leaders in the AI safety community. And so bringing together Topos scientists and the community in contact with people interested in questions of what AI will have for humanity in the coming decades. Over this sort of northern summer, we began to open up physical spaces. So we've opened up this office in Berkeley, which we're in, and the satellite office in Oxford, and also begin to hopefully have more of a web presence that those of you following online can really engage with. So we have this blog and Twitter and so on. And I think that's been a big achievement sort of through the summer to create this sort of community and physical presence. And this continued with a really joyous summer visiting program that was also very productive. I mean, we have these 2 draft books, one by David Jais Myers on the call on categorical systems theory, and then this book on polynomial functors that Nelson Yu and David Spivaka have written, which is an accompanying live stream course from this room. And sort of more of this work on, this is a slide on some work on epidemiology using these CatLab, Algebraic Julia sort of integrated methods. And you see the code, the sort of diagrams, and the actual results of the simulations. And then through the past few months, we've really begun to consolidate and build this foundation, sort of some great scientific work, which I won't get into too much, but also this strategic work and building the community through things like the MCAT seminar, but really aligning on what we're doing together, creating plans for the future and a pathway to carrying it out. And so it really is about this community. And you'll notice, I mean, some faces here will be familiar from the colloquium, but there's really a large team behind this organization, and it's a brilliant, passionate, inspiring team. So across the top, you see sort of the people more present in the Berkeley office, but we have the board on this left-hand side and our senior advisors over here, and a bunch of people in Europe and so on, all contributing to this I think, long-term and big project. And of course, we have a bunch of sponsors, some related to the previous slide too, to the people on the previous slide. But we're of course very grateful for their role in making this a possibility. So with that, I'll bring this event and the year of Topos to a close. But again, thank you to everyone who's participated in this project. Thank you all for being here. I hope you have a restful break over the coming new year, and we look forward to seeing you all for a great year in 2022. So thanks, everyone.